Now we're going to look at how to find the equation of the inverse of a function when you're given the equation of a function. First, let's look at the example of giving directions. If you were to give someone directions as to how to walk from the Air Canada Centre to Yonge and Bloor in Toronto, you would tell them walk 250 meters north, then walk 250 meters east, and then walk 2.7 kilometers north. Now, if you wanted to give someone directions to walk back from Yonge and Bloor to the Air Canada Centre, you'd have to tell them walk 2.7 kilometers south, then walk 250 meters west, and then walk 250 meters south. There are other ways you could go, but if you wanted to reverse the original directions, you would have to do that. Now notice that what we're doing here is, in order to undo the original function, which is what the inverse does, we're taking the reverse actions and doing them in the reverse order. So in order to walk back along the same path that you walked there, you have to turn the order around and turn the directions around. In other words, reverse the actions and reverse the order. And the same thing is going to be true when we look at inverses mathematically. So find the equation of the inverse of this function. Y is equal to 3x plus 2 divided by 4. Well, first, let's consider what this function is doing. It's taking an input, x, and the first thing it's going to do is it's multiplying it by 3. So this is the first thing it does. Right? In order of operations, first thing you do is multiply by 3. Then it's adding 2. And then once it's added 2, the last thing you're going to do is you're going to divide by 4. So the steps are there, 1, 2, 3. So in order to reverse that, the inverse function would have to do the opposite actions in the opposite order. So whereas the initial function divided by 4 as the last step, the inverse function rather would have to take an input x and it would have to multiply it by 4 as the first step, because multiplying is the inverse or the opposite action from division. Then in the original, the second thing that we did, the second last thing that we did was adding 2. So again, working in this direction, the next thing we'd have to do would be subtract 2. And because the first thing that we did in the original function was multiply by 3, the last thing we need to do in this inverse, again working up in that direction, is divide by 3. So whereas the first one multiplied by 3, added 2, and then divided by 4, now we multiply by 4, subtract 2, and then divide by 3. And we could use function notation here and write f inverse, but because we wrote a y here, we're going to write a y down here again. So these two functions are inverses of each other. This one should undo whatever that one did. If you put a number in here for x and got a number out for y, then if you plug that number in here for x, you should get out the same number for y as you started off putting in the beginning. It undoes whatever you did in the first place. Okay, let's look at a slightly simpler way of doing that. Again, we're looking at the same function, y is equal to 3x plus 2 over 4. Now remember that the inverse swaps the input and the output from the original function. So what we're going to do here is we're just going to swap x and y. So x is equal to 3y plus 2 over 4. Now, because we've swapped the input and the output, this is now the inverse of this function. However, it's not really common to leave a function in this form. We usually want y isolated, so we're going to re-isolate y. To do that, we multiply both sides by 4. We get 4x is equal to 3y plus 2. Now we're going to move the 2 onto the opposite side, get 4x minus 2 is equal to 3y. And to get rid of that 3, we're going to divide both sides by 3. So we get 4x minus 2 divided by 3 is equal to y. Notice that the result we got from swapping x and y and then re-isolating y is the same as the result we got from doing the opposite actions in the reverse order. So either way would be fine. There you go. So that is how to find the equation of the inverse of a function.